So we'll be starting with mixtures and allegations. Mixtures and allegation or allegations. See, what happens here is that we have one mixture, let's assume that's A, and we have another mixture that's B, assuming that's B. Both of them are mixed in some sort of a ratio, and then a mixture, third mixture C is formed, and that third mixture C has the contents of A as well as that of B. So that is when mixing happens. Okay. So we have a very limited set of questions, a very limited set of concepts which we need to study to understand mixtures and allegations. But the only important part which I would want you to learn is allegation. See, what happens in allegation is this. Let's assume that A was contributing 10 students of his, and B was contributing 20 students of his. Then the mixture was created in which 15 students were present. Okay, 15 students were present. So you'll have to tell in what ratio did A and B contribute together. So in this kind of a situation, we have to find out the difference between 15 and 10, which is nothing but 5, and the difference between 20 and 15, which is nothing but 5. This means this is 5 is to 5. When it gets cancelled, it becomes 1 is to 1. When I say 1 is to 1, I mean to say that both of them were contributing equally. Okay. So that means that A contributed 10 students and B contributed 20 students, but they contributed them equally. Okay. So in this situation, when the output is somewhere lying somewhere in the center, that is where we use the allegation method. Okay. My explanations might not be fulfilling enough for your brain to understand what I'm talking about, but the questions would be really, like, what should I say, the questions which have been asked till now by SSC, they are really easy, and all the basic concepts of ratios, that of percentages, and what, I think ratios and percentages, only these two concepts, and also that of averages, especially weighted weighted averages. Okay. So these three are the main concepts which you need to know. And even if some questions from mixtures might come up, you need not know any extra formulas, you need not know any extra concepts. The concepts would be derived from these three chapters only: ratios, averages, ratios, percentages, and averages. Okay. Moving on to the first question: in what proportion must tea at 62 rupees per kg be mixed with tea at 72 rupees per kg in order to obtain the mixture worth rupees 65 rupees per kg? This is the same allegation concept which I tried to explain you over there. This is the first mixture, that is A. This is the second, I won't say a mixture, this is the first quantity. This is the second quantity. Their prices have been written as 62 and 72, and the central quantity which comes out to be the final mixture's worth is 65 rupees. So here I would write 65 minus 62, and here I would write 72 minus 65. You always have to have a positive answer in this. Okay, you always have to have a positive answer in this because ratios cannot be negative in nature, right? Ratios cannot be negative in nature. So here 65 minus 62 is valid because it will give me a positive answer. Similarly, 72 minus 65 is also valid because it will give me a positive answer. 72 minus 65 would give me 7, and 65 minus 62 will give me 3. So the ratio that I was looking for was 73 is to 72. Okay, the ratio that I was looking for was 73 is to 7 is to, sorry, 7 is to 3. I hope you got it. The questions are considerably going to be shorter as compared to all the things which we learned in the past. So try to keep up with me. Similar question, we have the same capacities which are coming in and which are being poured out. Let's assume that in A and in B, these were two different quantities or two different mixtures. Okay. And the ratio was x into y, x is to y, and the ratio here was p is to q. When both of them are mixed, let's assume both of them are mixed in the ratio of small a is to small b, and a mixture is finally formed. The mixture is C, capital C, which is finally formed. So when you're supposed to add them up, the first thing that you're supposed to do is this a would be multiplied by, the small a would be multiplied by x and y, and the small b would be multiplied by p and q. Also, the sum of x plus y, which is associated with a, and the sum of p plus q, which is associated with b, would be cross multiplied. Okay, the sum of the ratios would be cross multiplied. This is the most important feature. Sum of ratios to be cross multiplied. Okay, the sum of the ratios would be cross multiplied, but the quantities in which, the quantities in which the ratios are like present, they would be self multiplied. Like a would be multiplied by a and small b would be multiplied by that of b. So the output would be somewhat like this, that x is to y would remain constant over here, p is to q would remain constant over here. This entire thing would be multiplied by small a, which is its own quantity. This entire situation, p is to q, would be multiplied by small b, which is its own quantity. In the end, x plus y would be multiplied by p plus q, and p plus q would be multiplied by x plus y. Again, the explanations would not be sufficient because they are very, very practical. Mixture and alligation is already in itself an explanation or an application of ratios. So when I'm trying to explain the explanation, it's going to be a little difficult, or explain the application is going to be a little difficult. So I would always need examples for that, right? For that matter, I would always need examples to my rescue. So I'll quickly take you to the examples. So, two bottles of the same capacity are 35% and 33 and 33 1 by 3% full of orange juice. Okay, I'll only talk about orange juice right now. This, there is orange juice. They are filled up completely with apple juice, and then the contents of both the bottles are emptied into another vessel. The percentage of apple juice in the mixture is what? Okay, the percentage of apple juice in the mixture is what? Let's assume the first case when only orange juice is present. This is the first bottle, this is the second bottle. It says 35% of orange juice is there in the bottle, and the rest is empty. How do I get to know that the rest of the bottle is empty? Because in the second case, apple juice is being filled up. Okay, so this is a very clear assumption that in the first case, the bottle is empty. Like, other than the 35%, which is the 65% portion, it is empty. When I say 35%, I'll do the calculations here. When I say 35%, I can very conveniently say that 7 out of 20 portion we are talking about, right? How do I get to this? You should read the percentage chapter for this. Or how do I still come to this? 35% can be replaced by 35 upon 100. 5 sevens are 35 and 5 twos are 20. So 7 by 20. You need not go to the percentages chapter now. Okay. So 7 by 20, we are here at 7 by 20. So for A, there is 7 upon 20. Talking about B, B's ratio is 33 1 by 3. This is very conveniently 1 by 3. Okay, this is very conveniently 1 by 3. So here I can say that in bottle A, out of 20 empty spaces, 7 spaces have been filled by orange juice. Similarly, in bottle B, out of 3 empty spaces, 1 empty space has already been filled by orange juice. Now comes into the picture apple juice. Now comes into the picture apple juice. Apple juice would be topping it up. Okay, it will be topping it up means it will be filling the bottle till the brim. So what do I do with that? Again, I have A and I have B. If apple juice is being filled in A, if apple juice is being filled in A, that means there was a 13 portion gap which was pending. There was a 13 portion gap which was pending, and the 13 portion gap and the 13 portion gap. So 13 portions out of 20 portions have been occupied by apple juice. Now, similarly, in the situation of B, we have 2 portions out of 3 portions which are filled by apple juice. Now, after both of them are added up together or after both of them are mixed, the question is what is the percentage of apple juice in the mixture? Okay, what is the percentage of apple juice in the mixture? So, what's happening here is I'll be now mixing A and B together. What are the bases of A and B? What are the bases of A and B? When I say the base, I mean to say what is in the denominator of A and B. We were assuming that the bottle is that of 20 here, and for B, the bottle is that of 3. So this is not possible because both of them are supposed to be of the same capacity. To make that happen, I will have to take the LCM of 3 and 20. For that, the LCM of 3 and 20 is that of 60. So the LCM is 60. That means with A, I'll have to multiply 3, which makes it 60. And with B, I'll have to multiply it by 20, which makes it another 60. So I have 60 and 60 equal now. So for every calculation that I have done in B, I will have to multiply it by 20. And for every calculation that I have done with A, I'll have to multiply it by 3. Okay, so I'll multiply it by 3 both up and down. Up and down means both numerator and denominator. This means 21 upon 60. And for B, this means 20 upon 60. Here itself, here as well, 39 upon 60. And here as well, 40 upon 60. So I have my quantities in place. The orange juice is clear. The apple juice is clear. So I'll quickly add up the orange juice first. The orange juice is 21 by 60 plus 20 by 60. This is orange juice, okay, or OJ. Then talking about AJ, that is the apple juice, that is 39 upon 60 plus 40 upon 60, right? So here I need to find out the apple juice percentage. The percentage that I am come up with is 79 upon 60. But this upon 60 is no more valid because both of them had 60 capacity each. When 60 plus 60 comes into place, it makes it 120. So 79 upon 120 would be my answer. I need to give the percentage of it. So 12 sevens are 84, 12 6 are, no, 12 6 are 72. So 72 plus 7. So 6, no, no, 5, 5-ish. Yeah. So it's going to be somewhere around 65%. Okay. Somewhere around 65% is going to be my answer. Yeah. Yeah. 65% is going to be my answer. Okay. Moving on. Two vessels of equal capacity of juice and water are in the ratio 3 is to 5 and 3 is to 1. The mixture of both the vessels are mixed and transferred into a bigger vessel. What is the ratio of juice and water in the new mixture? Okay. This is the same thing, the same quantity way. There is 3 is to 5 and there is 3 is to 1. 3 is to 5 and 3 is to 1. The sum of 3 is to 5 is 8. The sum of 3 is to 1 is 4. This would get cross multiplied. This would go here. This would go there, here and there, right? So 4 threes are 12. 4 fives are 20. This is that of A, the first one. Talking about the second one, B, 8 is being multiplied here. 8 threes are 24 and 8 ones are 8. 12 plus 24 is 36. 36 is to 20 plus 8 is 28. Okay. So 36 is to 28. 4 nines are 36. 4 sevens are 28. So 9 is to 7 is my answer. Right? 9 is to 7 is my answer. See, if I sit and try to explain your concepts, you won't get much out of it. You'll get most of the concepts out of the questions itself. Okay. So they are now being poured in different ratios. When here they were equal in quantity, but there was no mention of any ratio in which they were being poured. The only difference that is going to come is that any ratio in which A is being poured, let's assume that is X, and let's assume that B is being poured in the ratio Y, then X and Y would be multiplied respectively to the same side of the ratio. They would not be cross multiplied. So that is what my next concept talks about. Okay, that is what my next concept talks about. Let me take you there. P and Q are two alloys of aluminium and copper. Okay, P and Q both have aluminium is to copper in them. Aluminium is to copper in them. The ratios of aluminium and copper are P and Q are 5 is to 11 and 3 is to 5. If a third alloy is formed by mixing P and Q in the ratio of 1 is to 3, that means 1 is to 3 would be the self ratio in which they would be mixed. So they would be multiplied on the same side. I'll quickly add it up. 5 plus 11 is 16. 3 plus 5 is 8. 8 would be cross multiplied here and 16 would be cross multiplied here. I'll quickly write it down. 5 is to 11. Then 3 is to 5. 5 is to 11 and 3 is to 5. 8 is being multiplied on the left hand side. I'll quickly put them in a big bracket and multiply 8 here, and 16 would be multiplied here. 1 would be multiplied here and 3 would be multiplied here. So now, just to save a little more time, this 8 can be cancelled out with 16. 8 ones are 8, 8 twos are 16. Now, when 1 is multiplied by 5 is to 11, the output is going to be again 5 is to 11. In the other portion, 6 would be multiplied here. So 6 threes are 18 and 6 fives are 30. So 18 plus 15 makes it 23 and 30 plus 11 makes it 41. Okay, 41. So what then aluminum is what percentage of copper in the third alloy? Aluminum, this is aluminum and this is copper. Aluminum is to copper. So it's asking about what percentage of copper is aluminum, right? So it's simply asking me not 24, this is 23 upon 41 multiplied by 100. This is all it is asking me. So what I'll do is I'll quickly try to solve it in a round off way. 4 ones are 4, 4 fives are 20, and I think somewhere around 57%. Yeah. So roughly 57 or 56% would be the answer. Okay. I hope I have made myself very clear here. Yeah. I'll quickly move on to the next question. If now, as I told you, that averages would also play a very vital role, and especially that of weighted averages. Especially that of weighted averages. There is 36 liter of a solution and its potency is 20%. Similarly, there is 48% of there is 48 liters of a solution with 10% potency. Now, then what will be the percentage concentration of milk in the final solution? Okay, the percentage concentration of milk in the final solution. For this particular purpose, what I'll do is I'll use the averages formula. The ratios or the quantities in which they have been mentioned are cancelable. Okay, so 12 threes are 36, 12 fours are 48. Okay, 12 threes are 36, 12 fours are 48, and we only need to find out the answer in percentages. So the absolute value do not matter, the ratios would matter now. So 3 is to 4 we have it. If 10 is the base percentage, there is a gap of plus 10 percentage which is being created by the ratio 3, and it is being supplied to all the ratios together, which is 3 plus 4. This was the base 10% which we were talking about. This means 10% plus 10% into 3 upon 7, right? This 10% into 3 makes it 30. 30 upon 7 makes it 7 fours are 28 and 4.28%. And this 10% stays. Okay, this 10% stays. This makes it 14.28% as my answer. Okay, this makes 14.28% as my answer. Okay, this was a concept based on weighted averages. That is why this solution or this way was followed. Moving to the next question. Yeah, this is almost very similar to the one which we did in the past. A solution contains 10% acid. Solution B contains 30% acid. In what ratio should solution A be mixed with solution B to obtain a mixture with 25% acid? When three very much comparable quantities are mentioned, you can always, without batting a single eyelid, take alligation's route. Okay, so the gap is 15%, the gap is 5%, the percentage signs would get cancelled. 5 ones are 5 and 5 threes are 15. So the final answer would be 1 is to 3. See how quickly I'm jumping to conclusions. Okay, moving on. Milk and water are in two vessels A and B in the ratio 5 is to 3 and 2 is to 3. In what ratio should the liquid in both the vessels be mixed so as to obtain a new mixture in the vessel C containing half milk and half water? What most of the people do is that they write 5 is to 3 and 2 is to 3 and 1 is to 1 in forming alligations. This is the wrong method to go about it. You need to have, you need to follow this method. You need to have milk upon solution, then milk upon solution, and milk upon solution. This is the alligation pattern that we will have to follow. Okay, this is the alligation pattern which we'll have to follow. So milk upon solution in the first case comes out to be 5 is to 8. Milk upon solution in the second case comes to be 3 is to 2 is to 5. And milk upon solution in the final mixture comes out to be 1 by 2, because it's asking half milk and half water. This means 1 is to 1, or 1 upon 1 plus 1, which is 1 by 2. I'll solve it here more neatly. 5 by 8, 2 by 5, 1 by 2. Okay, this gives me 5 by 8 minus 4 by 8, which is equal to 1 by 8. Then 2 by 5 minus 1 by 2 would make it what? Again 1 by 10, if I'm not wrong. This would make it 1 by 10. Now the differences are, or the ratios, simple ratios are 1 by 10 is to 1 by 8. I would need to cross multiply it. 8 is to 10. Again, just one more step of simplification. 4 is to 5. So 4 is to 5 is my final answer over here. I hope you get it. I hope you're able to understand what I'm talking about. Moving on. When quantities are added in the mixture, find the final ratio. Okay, I'll take you to the question directly so that you build up better confidence. Okay, you build up better confidence to solve it. An alloy contains copper and tin in the ratio 3 is to 2. If 250 grams of copper is added, it becomes double. An alloy contains copper and tin in the ratio. Okay, this is copper Cu, tin is Sn, in the ratio 3 is to 2. Okay, these are standard chemical names of copper and tin, Cu and Sn. If 250 grams of copper is added to this alloy, then copper in it becomes double the quantity of tin. Copper becomes double the quantity of tin. That means the final ratio which comes out, this was the initial ratio. Okay, this was the initial ratio. The final ratio comes out to be 2 is to 1. Okay, 2 is to 1. Then what is the amount of tin in the alloy? Just look at what I'm talking about. There was an addition of 250 grams of copper in the picture. The quantity of tin remains the same. If the ratio value of tin is 2 in the beginning, I will have to forcefully assume that in the final level as well, The value of tin should be same. If not same, I will have to multiply it by 2. If tin is being multiplied by 2, then copper would also be multiplied by 2, because that would keep my ratios stable. This would become 4 is to 2. The final ratio is not getting disbalanced because of my operation of multiplying 2, so as to bring the quantity of tin to be equal in both the cases. Why am I ensuring that tin's quantity doesn't go haywire? There is a reason behind it, and the reason is that tin is not being touched from the initial level to the final level. Tin is not being touched, it is not being taken out, no new tin is being added, only copper is being tweaked. When only copper is being tweaked, then I must ensure that the quantity of tin remains the same, at least in the sense of ratios. Okay, at least in the sense of ratios. So in the sense of ratios, I have made sure that tin remains the same, right? So my new equation comes out to be 3 is to 2 and 4 is to 2. This is Sn or tin, and this is Cu, which is copper. Now, there is a gap of 1 unit which has been created by the addition of 250 grams of copper. So I can easily say that 1 unit ratio is equal to 250 grams. When it asks me the amount of tin in grams, I can say that I have 2 units of tin, 2 units of tin, which is nothing but 2 multiplied by 250, or 500 grams. Okay, 2 multiplied by 250 or 500 grams, and that is the amount of tin in the alloy. Good enough. I'll move on. If 60 liters of a milk solution has, this is not have, this is has 40% milk in it, then how much milk should be added to make the milk 60% in the solution? Okay, I'll use basic proportion. I won't be using anything beyond that. Okay, it says 60 liters of milk, and this is not pure milk, this is a milk solution. This means that there might be a little bit of water in it. There might be a little bit of water in it. So it says it is 40% pure. It is 40% pure, which also means that 40% of 60 is nothing but 24 liters. 24 liters milk, and how much water? Water is 36 liters water. Cool enough. Then how much milk should be added to make the milk 60% in the solution? Okay. Now, if some new milk is supposed to be added to the solution, I have to ensure that water remains constant. That means in the new mixture, 36-liter water would again be there, right? 36 liters water will again be there. Now, the milk which is supposed to come over here, it's nothing but 60% pure. It is 60% pure, right? When 60% pure milk is there, I can easily assume that 40% water would be in the picture. 40% water would be in the picture. If 40% water in the picture is equal to 36 liters of water, then 100% of any quantity would be equal to 90 liters of the mixture, right? Also, 60% of any quantity would be equal to 54 liters of any quantity. That means the 60% purity that we are talking about is because of 54 liters milk, or 54 liters pure milk being present. Initially, there was 24 liters milk present, but now there is 54 liters milk present. That means there is an upheaval or there is a jump of 30 liters milk in it, right? So 30 liters is my answer. 30 liters is my answer. I hope I've made myself very clear. Moving on. Now, process of removal and the process of replacement. Let's assume there was a mixture with 10 mixture which was pure. Okay, the mixture was pure. Now, there was 10% replacement. What do I mean by 10% replacement? If I have 100 liters of a solution, or let's say if I have 100 units of a solution, and I talk about 10 liters of replacement, 10% of replacement, it means I am removing 10 liters out of it. That means, and this is pure, pure liquid. Okay, this is nothing but pure liquid. If I replace it once, then there is a 10% decrease, which brings it down to 90 liters. Again, there is a 10% replacement, there is a 10% decrease. 90's 10% is 81, or 90% is 81. That means 9 liters is being replaced. So this would come down to 81 liters pure form of content. Then again, if I multiply it by 9 again, this would come down to 72.9 liters, and so on so forth. The questions which come for this particular process are in such a manner that they talk about 100% pure mixture being there. There was a 100 minus n% replacement whole upon 100. Then we are supposed to raise it to the power n, and n means number of times replacement occurred. Okay, n denotes number of times replacement occurred. In a similar way, in a shorter way, I would say it is nothing but 100 minus r upon 100 whole raised to the power n. Okay, this is my formula. This would be the replaced quantity. This would be the final mixture. I'll take you to the question so as to help you better. A container contains 25 liters of pure milk. From this container, 5 liters of milk is taken out and replaced by water. This process is further repeated 2 times. How much milk is there in the container now? Okay, we start with 25 liters. 5 liters is being replaced. I'll quickly take it to the kind of percentages. Okay, I'll take it to the kind of percentages. I can easily say that 5 upon 25 into 100 is nothing but 20%. This is what I wrote here, that there is a 20% replacement. If there is a 20% replacement, I would write 100 minus 20% whole upon 100 to the power what? The replacement was done further 2 times. This means a total of 3 replacements were done. This is the first replacement, and these are plus 2 replacements, which makes them 3 replacements. 100 minus 20 whole upon 100. 100 minus 20 makes it 80. 80 upon 100 is right here. This comes out to be 4 upon 5 whole raised to the power 3. 4 cube is 64, and 5 cube is 125. How much milk is there in the container now? This is the question. The percentage or the ratio of milk left behind is 64 upon 125. If I multiply the same with 25 liters of pure milk, 25 liters of pure milk, I will get my answer. 25 ones are 25 fives are. Okay, this would give me my answer, which is nothing but 12.8 liters. So When we started off, we had 25 liters of pure milk, but only because of 5 liters of multiple replacements, 5 liters of 3 times replacement, we were left with only 12.8 liters of pure milk in the end. Okay, I hope you get it. I'll move on. From a cask milk containing 60, from a casket, I should say, milk containing 64 liters, 8 liters are drawn out, and the casket is again filled up with water. If the same process is repeated a second and a third time, this means the value of n is nothing but 3. The percentage, which was 64, it is being done with 8. So 8 upon 64 into 100. This is 1 za, this is 8 za. This would give me, I think, 12.5%. There's a 12.5% gap. I'll quickly do it. 100 minus 12.5 whole upon 100 to the power 3. This would come out to be 7 upon 8. I'll quickly do a cubing of it. 7 cube is 343, and the total mixtures cube is going to be 512. What will be the proportion of milk is to water? What I have over here is milk upon total. Okay, so out of 512, I would have to subtract 343. This would give me the answer as 169. Yeah, so my answer would be 343 is to 169. Okay, 343 is to 169 is my final answer. Moving ahead. Mm, yeah, we'll have to follow up with this. This is a really cool question. Wheat was worth 80 rupees per kg and 50 rupees per kg, and they were mixed together with a third kind of a mixture, which is 1 is to 2 is to 3. That is the ratio in which they were mixed. If the mixture is worth 75 rupees per kg, then the price of the third variety per kg would be equal to what? Okay, so this is a question of weighted averages, and just try to see what cool method I use to quickly solve it. For 80 kgs, there is, for 80 rupees per kg, 1 is being multiplied. For 50 rupees per kg, 2 units are being used, and for x rupees per kg, 3 units are being used. A total of 1 plus 2 plus 3 units are being used, and the final variety which comes out is 75 rupees per kg. So if 75 is multiplied by 1 plus 2 plus 3, this makes it 6. 75 into 6, 7 6 are 42. 42 means this is somewhere around 450. Yeah, 450 is the clear one. 80 plus 100 plus 3x. This 100 plus 80 makes it 180. 3x is equal to 180 minus, or 450 minus 180, which is nothing but 270. And the value of x is nothing but 90 per kg. See how well did I do it? Because I used the formulas of weighted averages. Okay, mixtures and alligations doesn't have anything of its own other than the concept of alligation. Everything else is picked up by different areas, like ratio proportions, like averages and weighted averages, and one more thing, percentages. Yeah, so only these three concepts are useful. Coming again, 60 per kg and 75 per kg, 65 per kg. Okay, 60, 75, 65. The ratio in which R1 and R2 were there are 10 is to 5 or 2 is to 1. Okay, so we have 2 is to 1 here. Moving on. When the two mixtures mixed in above concept are sold at profit, okay, there is a possibility that there is profit in the mixtures. Read the question. How many kgs of salt costing 28 rupees per kg must be mixed with 39.6 kg of salt costing 16 rupees per kg, so that the selling mixture at 29.9, there is a gain of 15%. There is a gain of 15%. Now, I'll first move to the end of the question and try to find out the real selling price of the mixture, or the real cost price of the mixture in towards the end, just before mixing. Okay, just before mixing, at what price did they fix that, okay, this is the base price, and then I will put my gain percentage of 15% on it. So if a gain percentage of 15% is there, I can assume that there is, the new cost price is 115%. Sorry, the new selling price is 115%. So the value of 115% is given to be 29.90. This means 23 upon 20, I've just removed the percentage sign, is equal to 29.90. This means 29.9 upon 23 into 20 would give me the cost price. Okay, would give me the cost price. I'll quickly follow it. 23 ones are 23, 23 ones are, and 23 threes are 13, twos are 26. There is a point available as well. So this makes it 26. 26 rupees is the cost price that we are talking about. The first one is 28, the second one is 16, the central one is 26. The one which is 28 kgs is at X, is at X. The one which is 16 rupees is at 39.6. I'll use alligation. Alligation brings me here to 2 and brings me here to 10. Right? 10 is to 2 is what I have. This comes down to 5 is to 1. If the value of 1 unit is 39.6, what is the value of 5 units? I'll simply multiply 5 with 39.6. The answer is nothing but 0 would be there. 5 6 are 30, 3 is here, 45, 48, 4, 5 3 is 15, 15 plus 4 is 19. So 198 kg, right? So 198 kg is my answer. I hope everybody is able to understand what I've done. I know I'm moving really quickly, but other than the concept of alligation, I believe everything is simple ratio and percentages only. Yep. So that's why my speed is justified. Okay, my speed is definitely justified here. Now, there are two varieties of rice. Variety 1 costs 100, variety 2 costs 120. The vendor mixed both the varieties and sold them for 121 rupees and gained 10%. What is the ratio? In 121 rupees, there is a 10% gain available. That means 110% is equal to 121. If I'll divide it here, 121 divided by 110 multiplied by 100, this would give me 11 tens are, 11 elevens are, 10 and 10 gone. This would give me 110 rupees as my cost price, or the amount just before the gain. Yeah. So I have 100 on one side, 120 on the other side, and 110 at the center. This gives me 10 here, 10 here, and this also gives me 10 here. So 10 is to 10, or 1 is to 1 is my answer. Pretty much it. So this was the last question of mixture and alligation. Okay, we've hardly done around 10 to 12 questions, and this chapter is as easy as it gets. What I would recommend you to do is, if you couldn't understand much, please take down notes and do them multiple times. If you still couldn't do much, do write to us, do write in the comments. If there's any particular question you don't know, you did not like, you didn't understand, do let us know about it. Okay, so that's me signing off, and we've done ratios. Like, why did I say ratios? We've done mixes and allegations in the best way possible. Thank you.